Hello class, today we're on 6.6 exponential word problems. This is our first day of doing it. We're going to be doing a few days of these word problems. But today's lesson is going to be in this form, this f of x equals a times b to the x over t. So this is the general form of an exponential function, right? We have an x in the exponent. And this a, when working with word problems, how we think about it, it's the initial or current amount of something. B is our growth rate, so how much is it growing or shrinking by? When I say growth rate, I don't strictly mean growth. Sometimes it can decay or get smaller as well. But that would be our growth rate. And T is how long it takes for the growth rate to happen. So sometimes the growth rate will be like 1 year or 3 weeks or 5 months, something like that. So with these word problems, the best way to do them is just to go straight into the examples, and let's do some together. So I wrote the general form here on top so we have it for reference. So here's the first example. You have 12 grams of a certain radioactive isotope that has a half-life of 1,535 years. Part 1, how many grams will be left after 3,000 years? And part 2, how long will it take for there to be 4 grams left? Now, here's the thing with these problems. I know that you guys don't have, or not all of us have calculators at home, so I would be okay if you just leave it the answers in log form. The answers will be in log form, but if you have a calculator, go ahead and type those into the calculator to see what the exact values are. I'll be doing that in this case for these examples. So let's see here. Our first step is we need to set up an equation. So we need to set up an equation that looks like this. So we need to find out what our a value is, what our b value is, and what our t value is. Of course, x is our input, so when we create the function, we're going to leave it just like that. However, we'll be plugging in different values after we have this. So let's see. Let's define our a, b, and c. Or not a, b, and c, our a, b, and t. Okay, so a is our current or initial amount. So how many or how much of this radioactive isotope do we have currently? Well, that's going to be 12. Our b is the growth rate, and you might not see it here right away, but hopefully this will get easier as we go through these. It has a half-life. A half-life is a naturally occurring phenomenon where it happens a lot with like medications or like radioactive isotopes and stuff, where it'll have a certain length where after that length, half of it will be left. And then after that same length again, half of that will be left, and so on. So it keeps having itself. So our B, this is a half-life. So this is going to be 1/2 or 0.5 if you're more of a decimal person. And then T, how long does it take for that half-life to happen? Well, in this case, it's an extraordinarily long time, 1,535 years. It's 1,535. So now all we need to do to create our function is just plug it in, those values into this general form. So our function in this case is going to be f of x is equal to a, which is 12, times b, which is 1/2, to the x over t power, or the x over 1535 power. And really quick, what is x? What does x represent is really what I'm asking. And x represents the years. So let's just write that down as well. X is in years. So let's start answering some of these questions. How many grams will be left after 3,000 years? Well, what kind of number is the 3,000? The 3,000 is in years, so it's going to be an x value. So what we're going to do is we're going to plug in 3,000 in for x. So we can say f of 3,000, remember that just means I'm plugging in 3,000 in for x, is equal to 12 times 1/2 to the 3,000 over 1535 power. And that's really it. I mean, if you have a calculator at home that can do this, I would recommend using it. So we can say 12 times 1 over 2 to the 3,000 divided by 1535 power. And it turns out that f of 3,000 is roughly 3.096. But again, if you do not have a calculator at home, I would be fine if you left it just like this. Okay? So either one of these answers would be fine. They're saying the same thing. So how many grams would be left after 3,000 years? Well, 3.096 grams. Okay? I guess I'll put grams there. All right. Now, how long will it take for there to be 4 grams left? Well, this is asking something different. It's not asking how many grams will be left after a certain time. It's asking for a certain time after how many grams are left. So this is not an x value because x represents years. So we can't plug in 4 for x. But what we're going to do is we're going to plug it in for f of x. So we're going to replace f of x with 4 because I want to know when will this relationship of 12 times 1/2 to the x over 1535 equal 4. So I'm just going to take our function and set it equal to 4. So 4 equals 12 times 1/2 to the x over 1535 power. And now we need to solve for x. So this is where we're going to be doing some math here. Let's see. So first, well, let's take it back to yesterday's lesson or our last lesson. And that when we were solving for these things, for these exponential or logarithmic functions, we had 3 steps, if you recall. We need to get the equation in one of the forms above, if necessary. And in these cases, it will be necessary. So we're in exponential form, so we want to get the base by itself, right? Because before we convert to a different form, we need the base by itself. And then step 2, we convert forms. And step 3, finish solving for x. So we're going to go through those same 3 steps here. It's not going to be any different. And the base in this case is 1/2. Remember, the base is whatever is being raised to the power. So I need to get rid of this 12. So what I'm going to do is I'm going to divide both sides by 12 since it's multiplied. And 4 over 12 is 1/3. So 1 over 3, and this cancels, is equal to 1/2 to the x over 1535 fifth power. So now we can convert it to our different form. So if we recall here, where did I put my, if we recall here, the base is to the x is equal to a, is same as log base b of a equals x. So let's put it into, let's convert it from this exponential form to this logarithmic form. So let's see, we're going to have log base b, and our base in this case is 1/2, times a, which is 1/3, is equal to our exponent, x. Well, in this case, it's x divided by 1535. A lot of fractions here. Now, we're almost done. We're not done just quite yet because x isn't by itself. So we need to finish solving for x, which means we need to multiply both sides by 1535 because x is being divided by it, so we need to do the opposite operation. So 1535, or times 1535, and then times, let's see, 1535. So what we're going to have, this is going to cancel for us, which is great, what we wanted. So we're going to have, let's see here, 1535 times log to the, or of base 1/2 of 1/3 is equal to x. And again, if you do not have a calculator at home, I would be perfectly fine if you left your answers just like this. However, if you do have a calculator that can do this, why don't you go ahead and plug it in? So we're going to do that together. So 1535 log base 1/2 of 1/3 is equal to 2,432. So x is equal to 2432.917. Go to the third decimal place. So what does that mean? Well, our question was, how long does it take for there to be 4 grams left? Well, that's going to happen after 2,432 years. Awesome. So that was our first example. We got 2 more. So let's go through these. You have 25 micrograms of a certain bacteria that is silly me. I should have put years. I can hear my high school math teachers yelling at me. Okay. So you have 25 micrograms of a certain bacteria that is expected to double every 12 years. So we want to know how many grams will be left after 20 years, and how long will it take for there to be 10 grams left. So let's again define our A, R, and T to create our function, A, B, and T. And then we'll discuss what x is as well. So our A is how much we currently have. That's 25 micrograms. So A is 25. B is our growth rate. Well, this case it is expected to double. So that means B is going to be 2. And then how long does it take for it to double? 12 years. So that's going to be our T, 12. And x is in years. Okay. So now we can just plug it into our formula. So we have f of x is equal to 25 times 2 to the x over 12th power. All right, awesome. So we have our function. Now we can answer these questions. How many grams will be left after 20 hours? Well, 20 years. Well, years, again, is an x value, so we're going to plug 20 in for x. So we're going to have f of 20 is equal to 25 times 2 to the 20 over 12th power. And we're done, right? That is if you don't have a calculator. If you do have a calculator, of course, go ahead and plug it in, which we will do right now. It's going to bother me. There we go. Okay. So 25 times 2 to the 20 over 12th power, and we get 79.37. So f of 20 is equal to 79.37. And what's our units here? What does that mean? Well, how many grams will be left? Well, that will be 79.37. Oh, not grams, micrograms. All right, awesome. And then how long will it take for there to be 10 grams left? Well, again, grams. We're talking about grams. Oh, sorry, micrograms. I goofed. These should say micrograms. I apologize. So again, this is a gram value. It's not a year value. So we're going to set our function equal to 10. So we're going to have 10 equals 25 times 2 to the x over 12th power. And then now we need to solve for x. So again, we want to get our base by itself. Our base in this case is 2. So let's divide both sides by 25. (10 over 25 is going to be 2/5 is equal to, this cancels, 2 to the x over 12th power. And then from here we can convert forms. So we're going to be converting to log base 2 of 2/5 is equal to x divided by 12. And then, of course, our last step, we just need to finish solving for x. So x is being divided by 12, so let's multiply both sides by 12. This will cancel, so we have 12 log base 2 of 2/5 is equal to x. And of course, this is our answer. But let's figure this out since we have the calculator. So 12 log base 2 of 2/5. Oops, something interesting here. This was another typo. This was supposed to say 100 grams, because think about it. This thing is, hopefully some of you caught this. This thing is growing, it's not shrinking. So, I want to know when there's 100 grams left. So, let's just fix that really quickly. I'll redo it on a different piece of paper, actually, since I'm out of room. I apologize for that. Hopefully you saw that I got a negative number in there, and that should make sense, or it should not make sense, because we're not going back in time, right? We're going forward in time. So that's how I knew that something was awry, but I didn't catch that previously, so I apologize. So let's set up our equation. We have 10. We want to know when it's 100 grams. So 100 equals 25 times 2 to the x over, what is it, 12? 12 power. Awesome. And then we divide by 25. So it's 4 is equal to 2 to the x over 12. So then we convert. Log base 2 of 4 is equal to x over 12. And then multiply both sides by 12. So we have 12 log base 2 of 4 is equal to x. And let's see. We should be getting a positive number now. Perfect. So x is 24. Sorry about that. That makes a lot more sense. So let's see. So this actually isn't our answer. Our answer was 12 log 2 of 4 is equal to x. And then x equaled 24. And what unit are we talking about? Well, that's 24 years. Awesome. I apologize about that. And then one last example. A town has a current population of 5,000 people and has a growth rate of 1.5 every year. So let's go ahead and define our AR&T. Notice our growth rate is given as a number this time. It's not doubling or halving, it's 1.15. So our A, how many people are currently in that town? That's going to be 5,000. Our B is our growth rate, and that's going to be this 1.15 over here. Oftentimes our growth rate is not a perfect doubling or halving. And then our T, how long does it take the growth rate to happen? Well, it's every year. So that means every 1 year. And then finally, what does our X represent? Our X represents years. Okay, so let's plug it into the general form to get our function. So we're going to have f of x is equal to 5,000 times 1.15 to the x over 1 power. All right. And can we simplify this? Yes, we can. X over the 1 power is the same thing as just saying to the x power, right? Because everything is technically over 1. So we can write f of x, because it's just going to make our math one step quicker later down the line. So 5,000, 1.15 to the x. Okay. So now what will be the population after 15 years? Well, years, that's an x value. So let's plug it in for x. So f of 15 is equal to 5,000 times 1.15 to the 15th power. And let's see what that gets us. And of course, this is our answer here. But if we can get a decimal approximation of that, let's do it. Okay, and so after 15 years, the population is going to be 40,685. And I'm going to round it to a whole number since we're talking about people here. So, f of 15 is equal to 40,685 people. Awesome. And then how long will it take for there to be 80,000 people? Well, let's set our function equal to 80,000. And let's see, we're going to divide both sides by 5,000. And I believe that's 16, yeah. Okay. So 16 is equal to 1.15 to the x. And then we can convert it to our different form here. So we're going to have log base 1.15 of 16 is equal to x. And let's plug that in and see what we get. And we get 19.838, and that would be in years. Awesome. So this is today's lesson. So hopefully we're feeling okay about this. So get started on the worksheet and let me know if you have any questions. Have a good day. Bye.